A rare visitor from deep space is currently flying through our solar system, and this one is mind-blowingly huge. 3. Atlas is barreling past at over 150,000 miles per hour and could stretch up to 12 miles across, making it the largest interstellar object ever detected. Unlike asteroids or comets born in our solar system, this cosmic wanderer originated from another star system entirely. But here's what has scientists both excited and concerned. 3. Atlas displays characteristics that don't match any natural object we've seen before. Could this massive visitor be something more than just space rock? A rare visitor from deep space. Deep in the cold emptiness between stars, objects drift for millions of years before occasionally entering our solar system as interstellar visitors. 3. Atlas represents only the third confirmed interstellar object ever detected, following the mysterious Oumuamua in 2017 and Comet 2 Borisov in 2019. What makes this discovery extraordinary isn't just its rarity, but its unprecedented size and unusual characteristics that have astronomers scrambling to understand its true nature. The object's hyperbolic trajectory proves it originated outside our solar system, traveling through interstellar space for potentially millions of years before entering our cosmic neighborhood. Larry Deneau, principal investigator of the Atlas Asteroid Survey, initially thought the detection was equipment error due to the object's enormous size and unusual brightness patterns. Unlike typical asteroids that reflect sunlight predictably, 3Y Atlas shows irregular brightness variations suggesting either a highly elongated shape or surface features unlike anything in our solar system. The discovery has triggered an international observational campaign involving dozens of telescopes worldwide as astronomers race to gather data before the object disappears back into the darkness of interstellar space. This visitor may hold secrets about planetary formation in distant star systems and possibly answer questions about the prevalence of life in the universe. The breaking discovery. Tuesday, July 1st, 2025, marked a turning point in astronomy, when the automated Atlas telescope system in Hawaii flagged an unusual moving object in its vast database of sky observations. Robert Warwick, the same astronomer who discovered Oumuamua, was monitoring the system when the computer algorithms detected something moving too fast to be a solar system object. Initial calculations suggested the object was following a hyperbolic trajectory, the telltale signature of an interstellar visitor passing through our cosmic neighborhood. The significance of this discovery cannot be overstated, as interstellar objects are extraordinarily rare, with astronomers estimating that only one passes within observable range every few years. 3I Atlas immediately became the most important astronomical target of 2025, with observatories worldwide redirecting their instruments to track this cosmic wanderer. The International Astronomical Union worked quickly to assign the official designation, marking it as the third confirmed interstellar object with the 3-1 prefix. Maria Womack, program director for NSF's Astronomy division, called the discovery a once-in-a-generation opportunity to study material from another star system. The object's detection validated new automated survey systems designed to catch these fleeting visitors before they disappear forever into deep space. The discovery story. Late June 2025 began like any other observing period for the Atlas Asteroid Survey, a system designed to detect potentially hazardous asteroids approaching Earth. The 4-telescope array across Hawaii and South Africa continuously scans the sky, taking images every few minutes and comparing them to identify moving objects. On June 28, the automated detection algorithms flagged an object with unusual motion characteristics in the constellation Lynx. Larry Deneau and his team initially dismissed it as a processing error, as the object appeared far too large and bright to be a typical asteroid at such distance. Confirmation observations using the Canada-France-Hawaii Telescope and Gemini Observatory revealed that the object was indeed real and moving at extraordinary speed. By July 3, enough observations had accumulated to calculate a precise orbit, confirming that 3-1 Atlas was following a hyperbolic path characteristic of interstellar objects. The Minor Planet Center in Cambridge, Massachusetts coordinated the global observational campaign, with telescopes from Chile to Australia contributing tracking data. Alan Fitzsimmons from Queen's University Belfast led spectroscopic observations that revealed the object's unusual surface composition, confirming it was unlike any known solar system body and validating its interstellar origin. a stranger in our midst. So, 3I/Atlas really defies every expectation scientists had about interstellar objects thanks to its extraordinary size and mysterious properties. It's moving at about 150,000 miles per hour relative to the Sun, which is, way faster than any natural body born in our solar system could achieve without some kind of external acceleration. Videofy from NASA's Jet Propulsion Laboratory calculated that 3I/Atlas measures between 6 to 12 miles across, making it potentially 100 times larger than Oumuamua and, honestly, the biggest interstellar visitor ever detected. The object's brightness varies dramatically over a 12-hour period, which suggests either an extremely elongated shape or maybe surface features that reflect light differently as it rotates. Unlike typical asteroids that maintain steady brightness, 3I/Atlas shows magnitude variations of 2.5, indicating a highly irregular structure. The German Aerospace Center noted that the object's albedo, its reflectivity, is unusually high, suggesting a composition that's really different from most solar system bodies. Thermal infrared observations by the Spitzer Space Telescope detected no heat signature, which implies the object is either extremely reflective or made of materials with, pretty unusual thermal properties. But most puzzling of all is the object's trajectory, which shows slight deviations from pure gravitational motion, kind of similar to the mysterious acceleration exhibited by Oumuamua, but honestly on a much larger scale. The predecessors. The story of interstellar object discovery actually began on October 19, 2017, when Robert Warwick spotted Oumuamua using the Pan-STARRS telescope. This cigar-shaped visitor, measuring roughly 400 meters long, showed some pretty strange properties, including unexplained acceleration and an unusually high reflectivity that totally baffled scientists. Abraham Loeb from Harvard University even controversially suggested Oumuamua might be artificial technology from an extraterrestrial civilization, a hypothesis that, really divided the scientific community. Just 2 years later, amateur astronomer Gennady Borisov discovered 2I/Borisov from his observatory in Crimea, providing the second confirmed interstellar visitor. Unlike the mysterious Oumuamua, Comet Borisov behaved exactly as astronomers expected, developing a typical comet tail and showing predictable outgassing as it approached the Sun. Stefano Bagnulo from Queen's University Belfast led studies revealing that Borisov had a composition similar to comets from our own outer solar system, suggesting, similar formation processes across different star systems. The contrast between Oumuamua's anomalies and Borisov's normalcy really established a baseline for what interstellar objects should look like. Now 3I/Atlas represents a third data point, and its unusual characteristics are once again challenging our understanding of what natural interstellar objects can be. The cosmic journey. 3I/Atlas entered our solar system from the direction of the constellation Lynx, following a trajectory that suggests it originated from the Vega star system, which is about 25 light-years away. Orbital dynamics specialist David Farnokia calculated that the object has been traveling through interstellar space for about 5 million years before entering our solar system in early 2025. The visitor's path will take it closest to the Sun in December 2025 at a distance of 0.7 astronomical units, so that's closer than Earth's orbit but not close enough to significantly heat its surface. 3I/Atlas will pass within 50 million kilometers of Mars in November 2025, providing a unique opportunity for spacecraft observations using the Mars Reconnaissance Orbiter and the European Mars Express. After its solar encounter, the object will be gravitationally accelerated by the Sun's gravity, eventually reaching speeds exceeding 200,000 miles per hour as it exits our solar system toward the constellation Pegasus. The entire journey through our solar system will span about 18 months, with the object remaining visible to large telescopes until mid-2026. NASA's trajectory analysis indicates that 3I/Atlas will never return, continuing its lonely journey through the galaxy for millions more years before, maybe, encountering another star system. A scientific gold mine. So, 3I/Atlas, it's honestly a once-in-a-lifetime chance for scientists to examine untouched material from another star system. And, this time we've got modern astronomical tools that just weren't around during earlier interstellar encounters. James Green, who used to lead NASA's Planetary Science Division, actually described this discovery as the most scientifically valuable interstellar object we've ever found. And that's really because of its size, how close it is, and, the advanced technology we can use to study it. The James Webb Space Telescope, for example, has set aside 50 hours just to observe this object, using infrared spectroscopy to hopefully uncover the chemical fingerprints of the star system it came from. And Michelle Bannister, over at the University of Canterbury, is heading up an international team that's using the Atacama Large Millimeter Array to hunt for molecular signatures that might tell us more about where and how this thing formed. Now, unlike Oumuamua, which you probably remember faded out of sight pretty quickly, 3I/Atlas is big enough that we can keep watching it for a much longer time and with several different instruments. Lucy Lim, a planetary scientist at NASA Goddard, pointed out that studying interstellar objects like this is really the only direct way we have to analyze material from other star systems, without, waiting centuries for an interstellar mission to get there. So, by looking at what this object is made of, we might learn whether the way planets form is pretty much the same everywhere, or if it changes a lot from one star system to another. And that could totally reshape our understanding of how exoplanets form and just how likely it is to find habitable worlds orbiting other stars. Unanswered questions. Despite months of intensive observation, 3I Atlas continues to puzzle scientists with anomalies that resist conventional explanation. Marco Micheli from the European Space Agency has detected slight non-gravitational acceleration, similar to Oumuamua, but without any visible outgassing or comet-like activity. The object's surface appears completely inert, showing no signs of water vapor, carbon monoxide, or dust emission despite approaching the sun's heating zone. Thermal modeling by Alan Harris suggests the object's interior temperature should be sufficient to sublimate ice, yet no outgassing has been detected by even the most sensitive instruments. The object's unusual brightness variations remain unexplained, with some astronomers proposing it might be tumbling chaotically through space rather than rotating normally. Spectroscopic analysis by Vishnu Reddy from the University of Arizona revealed a surface composition unlike any known asteroid or comet class, showing spectral features that don't match meteorite samples or solar system objects. Most perplexing is the object's perfect preservation. After millions of years in interstellar space, it shows no signs of cosmic ray damage or space weathering that should have altered its surface. These mysteries have led some researchers to question whether 3I Atlas formed through natural processes or represents something more exotic than conventional astronomical objects. The alien question. The unusual properties of 3I Atlas have reignited debates about the possibility of artificial objects traveling between star systems. Abraham Loeb, who previously proposed that Oumuamua might be extraterrestrial technology, has examined 3I Atlas data and noted several characteristics consistent with manufactured rather than natural origins. The object's high reflectivity, unusual shape, and lack of outgassing despite solar heating mirror the properties expected from artificial materials designed for interstellar travel. SETI Institute scientist Seth Shostak acknowledged that while natural explanations should be preferred, the object's anomalies warrant serious consideration of alternative hypotheses. Loeb's analysis suggests that if 3I Atlas were a light sail or probe, its large size would allow it to maintain structural integrity during million-year journeys between stars. However, most astronomers favor exotic natural explanations, with Daryl Seligman from the University of Chicago proposing that the object might be composed of unusual materials like solid hydrogen or nitrogen ice that wouldn't outgas detectably. NASA's position remains that extraordinary claims require extraordinary evidence, but the agency has allocated additional observation time to gather more data. The debate highlights how little we understand about the diversity of objects that can form in other star systems and travel through interstellar space. Observing the visitor. 3I Atlas has triggered the largest coordinated observational campaign in astronomical history, with over 100 telescopes worldwide contributing data to understand this mysterious visitor. NASA's Hubble Space Telescope provides high-resolution imaging capable of detecting surface features, while the James Webb Space Telescope analyzes infrared signatures that reveal composition and temperature. Ground-based observatories including Keck, Gemini, and the Very Large Telescope conduct continuous monitoring to track brightness variations and search for outgassing signatures. Radio telescopes led by the Green Bank Observatory and Arecibo successor facilities listen for any artificial signals, though none have been detected. Planetary radar systems at Goldstone and Arecibo attempt to map the object's shape and rotation, but its distance pushes the limits of current radar technology. Amateur astronomers worldwide contribute observations using increasingly sophisticated equipment, with citizen science projects analyzing thousands of images for subtle changes. ESA's Gaia spacecraft provides precise astrometry measurements crucial for tracking the object's trajectory and detecting any acceleration anomalies. The Spitzer Space Telescope, despite being retired, was briefly reactivated specifically to observe 3I Atlas using its infrared capabilities. This unprecedented global effort demonstrates how rare interstellar visitors unite the astronomical community in pursuit of understanding our cosmic neighborhood. 3I Atlas continues its journey through our solar system, carrying secrets from another world that may never be fully revealed. Whether it's an exotic natural object or something more extraordinary, this massive visitor has already revolutionized our understanding of what travels between the stars. As we develop better technology to detect and study these cosmic wanderers, each new discovery brings us closer to understanding our place in the galaxy. Subscribe to Stellar Tech for more groundbreaking discoveries that challenge everything we thought we knew about the universe and our cosmic neighborhood. It started as nothing more than a flicker in the data, a cold, silent speck moving far faster than anything that should have been out there. But then, the James Webb Space Telescope captured the first real image of 3I Atlas, confirming its presence and reigniting debates about its origin. Now traveling at 152,000 miles per hour from the depths of interstellar space, this mysterious visitor is rewriting what we know about cosmic travelers. The flicker in the data. The flicker in data that led to the discovery of 3I Atlas was first noticed by astronomer Larry Deneau using the Atlas survey system in early 2025. Initially, the object appeared as a faint point source barely distinguishable from background noise, traveling at an extraordinary speed that defied expectations. Rapid follow-up observations from telescopes worldwide confirmed its hyperbolic trajectory, indicating an interstellar origin beyond our solar system. The discovery highlighted the increasing capability of modern automated sky surveys and the importance of advanced image processing techniques in spotting elusive cosmic phenomena. 3I Atlas's initial data sparked excitement and mystery in equal measure, leading to widespread international scientific collaboration to understand its true nature. The detection demonstrated the effectiveness of coordinated astronomy projects working in concert across hemispheres to capture fleeting interstellar visitors. What began as a mere computational anomaly quickly evolved into one of the most significant astronomical discoveries of the decade, challenging our understanding of what travels through the void between stars and forcing scientists to reconsider fundamental assumptions about interstellar objects. 152,000 mph from the void. Moving at an incredible velocity of approximately 152,000 miles per hour, 3I Atlas stands as one of the fastest objects ever recorded within our solar system's boundaries. Its extraordinary speed distinguishes it from typical asteroids or comets native to our cosmic neighborhood, definitively confirming its extragalactic origins. The precise velocity measurements were obtained using combined data from the Hubble Space Telescope and ground-based observatories worldwide. This phenomenal speed suggests a trajectory completely uninfluenced by our sun's gravitational pull, affirming that 3I Atlas is truly a visitor from another star system. Scientists involved in tracking the object, including Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory, are racing against time to gather detailed observations before it disappears forever into the cosmic void. The object's rapid passage through our observational field poses unprecedented challenges for data collection, requiring lightning-fast coordination among observatories globally to maximize information retrieval during its brief transit. Such extraordinary velocity raises fundamental questions about the forces that accelerated this object to such speeds and whether natural processes alone could account for its remarkable journey through interstellar space. 3 visitors, 7 years. Over the span of 7 years, humanity has documented the arrival of 3 confirmed interstellar visitors: Oumuamua in 2017, 2I Borisov in 2019, and now 3I Atlas in 2025. Each visitor has brought unique characteristics that challenge our understanding of interstellar objects and their origins. Oumuamua puzzled scientists with its cigar-like shape and unexplained acceleration, while 2I Borisov displayed traditional comet behavior with visible outgassing. 3Y Atlas represents perhaps the most enigmatic of the three, combining unprecedented size with unusual physical properties. The increasing frequency of these detections suggests either improved observational capabilities or a genuine increase in interstellar traffic through our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast notes that statistical models predicted we should encounter one interstellar object every few years, yet the diversity among our three visitors exceeds all theoretical expectations. This pattern has prompted astronomers to reconsider whether we're witnessing random cosmic wanderers or something more systematic. The progression from Oumuamua's mysteries to 3I Atlas's apparent technological signatures suggests an escalating complexity that challenges conventional explanations for these cosmic visitors. James Webb's metallic discovery. Despite its immense size, 3I/Atlas exhibits distinctly metallic characteristics not commonly observed in natural celestial bodies traveling through space. Recently, the James Webb Space Telescope captured unprecedented infrared images revealing highly reflective surfaces and spectral signatures indicative of engineered materials rather than typical rocky or icy compositions. Dr. Jane Rigby from the Space Telescope Science Institute leads the comprehensive analysis of these groundbreaking findings that challenge conventional understanding of interstellar objects. The spacecraft's sophisticated instruments detected unusual heat emission patterns consistent with metallic alloys and composite materials rather than the typical signatures expected from cometary ices or rocky asteroids. These observations fundamentally challenge conventional cometary models and provide compelling evidence supporting theories about the object's potential artificial origin. The metallic properties suggest advanced engineering capabilities far beyond current human technology, with surface materials that appear designed to withstand the harsh conditions of interstellar space. The discovery has prompted intense international collaboration, as scientists attempt to understand how such materials could survive millions of years of cosmic radiation and micrometeorite bombardment during the object's journey between star systems. The machine that steers itself. Detailed tracking of 3I/Atlas reveals subtle but unmistakable evidence that it actively maneuvers through space, strongly suggesting the presence of an autonomous guidance system. Dr. Amir Siraj from Harvard University highlights observational data showing minute trajectory corrections that cannot be explained by gravitational influences or solar radiation pressure alone. These course adjustments occur with mathematical precision, indicating sophisticated onboard navigation capabilities. Experts hypothesize the presence of an advanced propulsion mechanism or intelligent navigation system actively controlling the object's path through our solar system. Such self-steering capability would represent a technological achievement far beyond anything in humanity's current arsenal, suggesting engineering by a civilization with capabilities we can barely comprehend. The subtle nature of these adjustments indicates a system designed for stealth and efficiency, rather than dramatic maneuvers. Analysis suggests the object may be following a predetermined flight path, possibly executing a systematic survey of our solar system's major bodies. This revelation intensifies scientific debates about whether 3I/Atlas represents a natural interstellar object, or an intelligently designed probe conducting reconnaissance of our cosmic neighborhood, with sophisticated artificial intelligence guiding its every movement. Information blackout. In recent months, astronomical observations of 3I/Atlas have been plagued by mysterious communication disruptions that some scientists describe as an emerging information blackout. Data streams from major observatories occasionally suffer unexplained interruptions, creating frustrating gaps in the continuous monitoring required for comprehensive analysis. Dr. Sarah Seeger from the Massachusetts Institute of Technology warns that these systematic blackouts are hindering critical data collection during the object's closest approach to Earth. The disruptions appear to follow patterns that cannot be attributed to equipment failures or atmospheric conditions, leading to speculation that the object may employ active measures to obscure detailed observation. Information loss challenges astronomers to devise innovative observational strategies and backup systems to maintain contact during the object's rapid transit. Some researchers theorize that 3I/Atlas possesses adaptive countermeasures designed to limit scrutiny from potential observers. The timing of these blackouts often coincides with moments when the most sensitive instruments would normally capture their highest quality data. This phenomenon has prompted the development of new redundant observation networks and the deployment of multiple independent systems to circumvent whatever mechanism might be causing these mysterious data interruptions. Adaptive shielding technology. Scientists, have developed theories suggesting that 3I/Atlas employs some kind of sophisticated adaptive shielding technology to survive the extreme conditions of interstellar space over, potentially millions of years. Dr. Monica Grady from the Open University explains that such advanced shielding systems might dynamically protect the object from cosmic radiation, solar particle streams, and micrometeorite impacts while maintaining its structural integrity. Evidence from variable brightness patterns and sophisticated thermal management systems supports this revolutionary hypothesis about the object's survival mechanisms. Now, these adaptive shields would enable prolonged operational capability during close stellar encounters, making the object far more than just a simple interstellar comet. If this theoretical technology is confirmed through continued observation, it would, quite frankly, fundamentally revolutionize human understanding of materials science and extraterrestrial engineering capabilities. The shielding appears to respond to environmental changes, adjusting its properties based on local radiation levels and particle densities. Such technology, it would require advanced sensors and automated response systems working in perfect coordination. The implications extend far beyond just academic interest, suggesting that 3I/Atlas represents an engineering achievement that could provide blueprints for humanity's own future interstellar missions. Understanding these protective mechanisms could unlock secrets essential for our survival during extended journeys between star systems. The Ancient Probe Network. So, recent theoretical frameworks propose that 3I/Atlas represents a component of an ancient probe network designed to systematically explore and monitor galactic environments across vast timescales. Dr. Frank Drake, founder of modern SETI research, has discussed the possibility of coordinated reconnaissance systems deployed by advanced civilizations to study emerging planetary systems throughout the galaxy. These theoretical probes might maintain communication through quantum entanglement or, other exotic mechanisms currently beyond human technological comprehension. Evidence suggests such a network could have been deployed millions or even billions of years ago by a highly advanced civilization with capabilities spanning galactic distances. The probes would operate with extreme longevity, possibly self-repairing and adapting to changing cosmic conditions over geological timescales. Exploring 3I/Atlas might offer unprecedented insights into this enigmatic interstellar monitoring system and reveal the intentions of its creators. The network hypothesis explains the increasing frequency of interstellar visitors and their apparent technological sophistication. Such a system would represent the ultimate expression of scientific curiosity and technological achievement, allowing a civilization to study the development of life and intelligence across thousands of star systems simultaneously, while, remaining largely undetected until their technology is sufficiently advanced for meaningful contact. Prime numbers in heat signatures. Scientists analyzing thermal emissions from 3I/Atlas have detected periodic fluctuations that correspond remarkably to prime number sequences, creating patterns unlikely to arise from any known natural process. Dr. Seth Shostak from the SETI Institute emphasizes that such mathematical precision in thermal signatures strongly indicates intentional signaling by an intelligent source rather than random physical phenomena. The presence of prime-numbered cycles in heat emissions represents a form of universal mathematical communication that any technologically advanced civilization would recognize. These observations add compelling evidence to theories that 3I/Atlas harbors sophisticated technological features specifically implemented to communicate or encode information for other intelligences. The mathematical precision of these thermal patterns suggests deliberate design rather than coincidental physical processes. Researchers are working to decode these numerical sequences, hoping they might contain more complex information about the object's origins or mission. The use of prime numbers as a communication method demonstrates sophisticated understanding of mathematics as a universal language. This discovery represents potentially the first confirmed technological signal from an extraterrestrial source, marking a watershed moment in humanity's search for cosmic intelligence and fundamentally altering our understanding of our place in the universe. We were never the observers. The accumulating evidence surrounding 3I/Atlas fundamentally challenges humanity's assumption that we are the primary observers of cosmic phenomena. Dr. Avi Loeb from Harvard University argues that this interstellar visitor demonstrates clear evidence of extraterrestrial intelligence actively monitoring and studying planetary systems throughout the galaxy. Observational data suggests these cosmic visitors are neither passive wanderers nor accidental tourists, but may represent fundamentally proactive agents in galactic scientific endeavors. This paradigm shift forces humanity to reconsider our place in the cosmic hierarchy and acknowledge the possibility that we have been subjects of study rather than the sole investigators. The revelation that advanced civilizations may have been observing Earth for extended periods alters philosophical and scientific perspectives about human uniqueness and cosmic significance. The systematic nature of these visits suggests a level of galactic organization and scientific methodology that, honestly, dwarfs human capabilities. Recognition that we may have always been monitored by superior intelligences challenges anthropocentric worldviews and demands humility in our cosmic perspective. This discovery marks the beginning of humanity's true integration into a galaxy populated by intelligence far exceeding our own technological and scientific achievements. The remarkable data captured by the James Webb Space Telescope has propelled humanity into a new era of cosmic discovery and understanding. As the secrets of 3I/Atlas continue to unfold, we find ourselves confronting the profound possibility that we are not alone in the universe. The ongoing study of this extraordinary visitor challenges our fundamental notions of life, technology, and our place in the cosmos. Stay with Stellar Tech as we continue following these groundbreaking developments, seeking truth among the stars, and preparing for humanity's next chapter in cosmic exploration. On July 1, 2025, astronomers detected something extraordinary racing through our solar system at 152,000 miles per hour. This wasn't just another space rock, it was 3I/Atlas, a massive interstellar comet from beyond our solar system, potentially up to 20 kilometers wide and billions of years older than Earth itself. Unlike the mysterious Oumuamua that puzzled scientists in 2017, this visitor is showing clear signs of cometary activity with a glowing tail stretching thousands of miles. Today we explore humanity's third confirmed interstellar visitor and what it reveals about the cosmos. The discovery that shook astronomy. The story begins with what seemed like routine observations at the Atlas Telescope facility in Rio Hurtado, Chile. On July 1, 2025, the asteroid terrestrial impact last alert system detected a faint object moving against the backdrop of stars near the constellation Sagittarius. Initially designated A11PL3Z, this seemingly ordinary discovery would soon revolutionize our understanding of interstellar visitors. Within hours, follow-up observations revealed something extraordinary. The object wasn't following a normal elliptical orbit around our sun like asteroids and comets from our solar system. Instead, it was traveling on a hyperbolic trajectory with an orbital eccentricity of 6.15, the highest ever recorded for any object in our solar system. This mathematical signature could only mean one thing: the object originated from interstellar space. Amateur astronomer Sam Dean played a crucial role by discovering pre-discovery images of the object dating back to June 14, allowing scientists to calculate its precise trajectory. The Minor Planet Center received over 100 confirmed observations from telescopes worldwide within 24 hours, officially designating it 3I/Atlas, the third confirmed interstellar object ever detected, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. A colossal visitor from deep space. What makes 3I/Atlas truly remarkable is its sheer size and speed. Traveling at approximately 152,000 miles per hour relative to our Sun, this interstellar giant could journey from Earth to the Moon in just over an hour. Early estimates suggest the comet's nucleus could be between 10 to 20 kilometers in diameter, making it potentially dozens of times larger than its predecessors. When Harvard astronomer Avi Loeb analyzed the brightness data, he discovered something striking. The object reflects an unusual amount of light for its distance, suggesting either a highly reflective surface or enormous size. If its surface is dark like most asteroids, 3I/Atlas would need to be roughly 24 kilometers across to produce such brightness, making it a true cosmic giant. Unlike the enigmatic Oumuamua, which showed no clear signs of cometary activity, 3I/Atlas immediately displayed classic comet behavior. Observations from the Nordic Optical Telescope by astronomers David Jewett and Jane Liu revealed a diffuse tail on July 2nd, while the TAID Twin Telescope Observatory recorded a tail stretching 25,000 kilometers. This active behavior confirms 3I/Atlas is indeed a comet, not an asteroid. A cosmic journey through our solar system. 3I/Atlas is currently positioned about 420 million miles from the Sun, roughly within Jupiter's orbit, racing inward on its one-way journey through our solar system. Its hyperbolic trajectory means it will never return. This is a single encounter that astronomers must maximize while the opportunity exists. The comet's path will bring it closest to Mars on October 2, 2025, passing within just 18 million miles of the red planet. Some researchers have proposed using NASA's Mars rovers to photograph the comet during this close approach, potentially providing unique surface-based images of an interstellar visitor. On October 29, 2025, 3I/Atlas will reach perihelion, its closest point to the Sun at approximately 130 million miles away, just inside Mars's orbit. At this point, it will be traveling at its maximum velocity of 68 kilometers per second. The comet will make its closest approach to Earth on December 19, 2025, though it will remain at a safe distance of 167 million miles. Throughout this journey, 3I/Atlas poses absolutely no threat to Earth. Its trajectory ensures it will pass safely through our solar system before continuing its eternal voyage into interstellar space. The oldest comet in the universe. So perhaps the most astounding aspect of 3I/Atlas is, honestly, just its incredible age. Research led by Matthew Hopkins at Oxford University suggests this interstellar visitor could be between 7.6 and 14 billion years old, potentially older than our entire solar system by more than 3 billion years. The key to understanding its ancient origins lies in its velocity and trajectory. With a hyperbolic excess velocity of 58 kilometers per second, 3I/Atlas is moving way faster than objects typically ejected from nearby star systems. This extreme speed suggests it originated from the Milky Way's thick disk, a region containing some of the galaxy's oldest stars, most of them over 10 billion years old. Professor Chris Lintott, co-author of the Oxford study and presenter of BBC's The Sky at Night, explains the significance. This is an object from a part of the galaxy we've never seen up close before. We think there's a 2/3 chance this comet is older than the solar system, and that it's been drifting through interstellar space ever since. If confirmed, 3I/Atlas would represent a pristine time capsule from the early universe, carrying materials that formed when the galaxy was young and star formation was just beginning. Global Telescope Network mobilizes. The discovery of 3I/Atlas has, well, triggered an unprecedented global observational campaign. Astronomers all around the world are pointing every available telescope at this rare visitor, knowing they've got only months before it disappears forever into the depths of space. The James Webb Space Telescope, with its massive 21.3-foot mirror and incredible infrared sensitivity, is perfectly positioned to study 3I/Atlas in detail. Webb can detect heat signatures and identify specific chemicals and minerals on the comet's surface, potentially revealing its composition and origin. The Hubble Space Telescope complements Webb's capabilities with its ultraviolet observations, providing a complete picture across different wavelengths of light. Ground-based observatories from Hawaii to Chile to South Africa are tracking the comet's movement, measuring its brightness changes, and analyzing the faint light it reflects. The European Space Agency is actively monitoring the object through multiple facilities, while the Instituto de Astrofísica de Canarias has contributed crucial observations using their Atlas TD telescope and the Gran Telescopio Canarias. Radio telescopes like the Very Large Array in New Mexico are also listening for any unusual emissions as the comet interacts with the solar wind, making sure no potential signals are missed during this historic encounter. Comparing interstellar visitors. 3I/Atlas joins, an exclusive club of confirmed interstellar objects, each with unique characteristics that really challenge our understanding of the cosmos. The first visitor, 1I/Oumuamua, discovered in October 2017, remains the most mysterious. Its cigar-like or pancake flat shape and unexplained acceleration as it left our solar system sparked intense debate, with scientists like Avi Loeb even suggesting it might be artificial technology. The second visitor, 2I/Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov, behaved more like a familiar comet with a visible tail and composition similar to comets in our solar system. Its nucleus was estimated at just 400 meters across, making it relatively small compared to 3I/Atlas. What sets 3I/Atlas apart is its combination of size, age, and clear cometary behavior. While Oumuamua showed no outgassing and Borisov was relatively young, 3I/Atlas displays active cometary features despite potentially being billions of years old. Its orbital eccentricity of 6.15 far exceeds both predecessors, indicating it's traveling much faster and likely originated from a more distant region of the galaxy. This progression from mysterious to familiar to ancient suggests interstellar objects are more diverse than we initially thought. Clues to galactic chemistry and life. While the composition of 3I/Atlas could, really revolutionize our understanding of how planets form throughout the galaxy. Early observations have detected a reddish coma surrounding the comet, which is actually pretty similar to what was seen in 2I/Borisov. This red coloration most likely comes from organic-rich dust containing these complex molecules called tholins, carbon-based compounds that scientists believe played a crucial role in the origin of life. If 3I/Atlas contains materials similar to comets in our own solar system, it would provide pretty powerful evidence that the building blocks of life are widespread throughout the galaxy. The presence of water ice, organic compounds, and complex chemistry would suggest that the ingredients for life aren't unique to Earth, but are actually common products of stellar evolution. On the other hand, if the comet's composition turns out to be entirely different from anything in our solar system, it would reveal the incredible diversity of conditions under which planetary systems can form. This could mean that 3I/Atlas formed around a star with different metallicity, or in a region of space with really unique chemical conditions. Either outcome would be scientifically revolutionary, either confirming the universality of life's ingredients or revealing new pathways for chemical evolution in the cosmos. Mysteries and unanswered questions. Mysteries and unanswered questions. Despite intensive observations, 3I/Atlas guards many secrets that continue to puzzle astronomers. One of the biggest mysteries is its exact size and rotation. While early estimates suggest a nucleus between 10 and 20 kilometers across, the active coma of gas and dust makes precise measurements challenging. Some observations suggest the comet might be tumbling chaotically rather than spinning smoothly, possibly indicating a violent past collision or gravitational encounter. The comet's unusual brightness remains another puzzle. Its high reflectivity could indicate a surface composition unlike anything in our solar system, or it might be experiencing an outburst that temporarily increases its brightness. Understanding this brightness is crucial for determining its true size and nature. As with previous interstellar visitors, some scientists are monitoring 3I/Atlas for any signs of non-gravitational acceleration, movement that can't be explained by gravity alone. While such acceleration is normal for comets due to outgassing, any unusual patterns could provide clues about the comet's internal structure or composition. The question of artificial origin, while highly unlikely, remains part of the scientific discussion. Avi Loeb has suggested using advanced telescopes to search for any signs of technology, though natural explanations are far more probable. Future missions and rapid response. Future missions and rapid response. The discovery of 3I/Atlas has accelerated discussions about rapid response missions to intercept future interstellar visitors. While this comet was discovered too late for any spacecraft to reach it, several space agencies are developing concepts for quick launch missions that could be deployed when the next interstellar object is detected. The European Space Agency's Comet Interceptor mission, scheduled for 2029, represents one approach to studying pristine comets. While originally designed for objects from our solar system, similar technology could be adapted for interstellar targets if sufficient warning time exists. The upcoming Vera C. Rubin Observatory will revolutionize interstellar object detection when it begins operations. Its enormous camera will photograph the entire visible sky every few nights, creating a movie of the cosmos that should detect multiple interstellar objects annually. Astronomers predict it might discover between 5 and 50 interstellar visitors during its 10-year legacy survey of space and time. This improved detection capability means future interstellar objects might be spotted months or even years before their closest approach, providing sufficient time to plan and launch intercept missions. Such missions could return samples from other star systems, bringing pieces of alien worlds directly to Earth for analysis. A new era of interstellar archaeology. A new era of interstellar archaeology. 3I/Atlas represents more than just another astronomical discovery. It marks the beginning of interstellar archaeology, the study of physical artifacts from other star systems. Each interstellar visitor carries information about distant worlds we may never visit, providing direct samples of materials that formed under completely different conditions than those in our solar system. The rapid succession of interstellar discoveries, 3 confirmed objects in less than a decade after centuries of seeing none, suggests these cosmic wanderers are far more common than previously thought. This frequency implies that planetary systems throughout the galaxy routinely eject material into interstellar space, creating a vast network of cosmic debris that connects star systems across the galaxy. As our detection capabilities improve and more interstellar objects are discovered, we'll begin to understand the diversity of planetary formation processes throughout the Milky Way. Each visitor provides a unique data point about stellar chemistry, planetary evolution, and the conditions that exist in different regions of our galaxy. 3I/Atlas, with its ancient age and pristine composition, offers a particularly valuable glimpse into the early universe, when the first generation of planets was forming around young stars billions of years ago. From its discovery in the Chilean desert to its journey through our solar system, 3I/Atlas has already transformed our understanding of interstellar visitors. This ancient comet, potentially older than our solar system itself, carries secrets from the early universe that could reshape our knowledge of planetary formation and the ingredients for life. As it continues its eternal voyage through the cosmos, 3I/Atlas reminds us that our solar system isn't isolated but part of a vast galactic community. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic discoveries. Fresh observations are now shedding new light on 3I/Atlas, the massive interstellar visitor that's been puzzling astronomers since its discovery. What started as excitement over finding our third interstellar object has transformed into something far more intriguing and honestly controversial. Recent data analysis reveals patterns that just shouldn't exist in natural objects. Orbital characteristics so precise they seem almost intentional. Professor Avi Loeb and other researchers are asking uncomfortable questions. What if 3I/Atlas isn't just a comet? What if it's something designed to study us while appearing completely natural? Fresh observations reveal mysteries. Recent months of intensive observation have transformed 3I/Atlas from an exciting discovery into astronomy's most controversial object since Oumuamua. Dr. Robert Warwick from the University of Hawaii, who led the discovery team, admits that new data has revealed characteristics that challenge our understanding of natural interstellar objects. The object's behavior patterns have proven increasingly difficult to explain through conventional comet models. Advanced spectroscopic analysis by the European Southern Observatory shows surface composition anomalies that don't match any known class of solar system bodies. Most puzzling is the object's thermal signature, or rather the lack thereof. Despite approaching within 0.7 AU of the Sun, 3I/Atlas shows minimal heat emission and no detectable outgassing. Dr. Michelle Bannister from the University of Canterbury noted that objects this size should be streaming gas and dust as they heat up, but we're seeing virtually nothing. The observations have split the astronomical community between those who believe there must be a natural explanation, and others who are beginning to consider more exotic possibilities. NASA's Deep Space Network continues tracking the object, but each new measurement seems to deepen rather than resolve the mystery. The scientific debate. The astronomical community finds itself divided over 3I/Atlas, with heated debates emerging at conferences and in scientific journals. Dr. Alan Fitzsimmons from Queen's University Belfast leads the conventional camp. arguing that extraordinary claims require extraordinary evidence, and we haven't reached that threshold yet. His team maintains that unusual properties can be explained by exotic but natural compositions, possibly involving nitrogen ice or other materials rare in our solar system. However, a growing faction of researchers questions this dismissive approach. Dr. Daryl Seligman from the University of Chicago, who previously proposed natural explanations for Oumuamua, admits that 3I/Atlas presents characteristics that are harder to reconcile with known natural processes. The debate intensified when thermal modeling by Dr. Marco Michelli from the European Space Agency revealed that the object's temperature distribution doesn't match any known natural body. Spectroscopic measurements show absorption lines that appear artificially narrow, suggesting either unknown physics or manufactured materials. Dr. Sarah Seeger from MIT cautioned against rushing to conclusions, but acknowledged that we may need to expand our definitions of what constitutes natural phenomena in interstellar space. The scientific method demands skepticism, yet the mounting anomalies are forcing astronomers to confront uncomfortable possibilities. The artificial origin hypothesis. Professor Abraham Loeb, former chair of Harvard's astronomy department, has emerged as the most vocal proponent of an artificial origin for 3I/Atlas. Building on his controversial Oumuamua research, Loeb argues that the object displays technological signatures that suggest intelligent design rather than natural formation. His analysis focuses on the object's perfect orbital mechanics, unusual surface properties, and lack of expected comet behavior. Loeb's calculations suggest that 3I/Atlas's trajectory shows statistical precision that would be virtually impossible to achieve naturally. The object's approach vector, timing, and encounters with multiple planets create what he calls a reconnaissance pattern consistent with systematic exploration. In his recent paper submitted to Astrophysical Journal Letters, Loeb proposes that 3I/Atlas could be a probe designed to study our solar system while maintaining the appearance of a natural comet. His hypothesis suggests that advanced civilizations might use such camouflaged objects to observe other star systems without detection. Critics argue that Loeb is making extraordinary leaps from limited data, but his mathematical analysis of the object's properties continues to gain attention from researchers who find conventional explanations increasingly inadequate for the mounting anomalies. Unusual detection pattern. The circumstances surrounding 3I/Atlas's discovery reveal troubling patterns that suggest possible stealth capabilities. Dr. Larry Deneau from the Atlas Asteroid Survey noted that the object should have been detected 18 months earlier, based on its size and trajectory, yet it remained invisible to all automated survey systems until July 2025. The delayed detection becomes even more suspicious when considering the object's approach vector from the constellation Lynx, a region of sky that multiple survey telescopes regularly monitor. Orbital reconstruction by Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory reveals that 3I/Atlas entered the outer solar system in January 2024, but somehow avoided detection despite passing through well-monitored space. The object's approach direction created additional observational challenges, as it remained positioned in areas of sky that were difficult to observe from Earth-based telescopes for extended periods. Dr. Catalina Donovan from the Linear program admitted that objects this bright should have triggered multiple detection systems, but somehow it remained hidden until practically on top of us. This pattern of avoiding detection until the last possible moment really raises questions about whether the concealment was accidental or intentional, adding weight to theories about possible artificial intelligence guiding the object's approach. Suspicious orbital characteristics. 3I/Atlas's orbital mechanics present statistical anomalies that challenge natural origin theories through their mathematical precision. Dr. Fatih Namouni from Côte d'Azur Observatory calculated that the object's perfect alignment with the ecliptic plane has only a 0.2% probability of occurring naturally for an interstellar visitor. More striking are the object's sequential close encounters with Venus, Mars, and Jupiter, which orbital dynamicist Dr. Mattia Galeazzo from the University of Vienna determined has only a 0.005% probability of happening by chance. The precision of these encounters suggests either extraordinary coincidence or deliberate trajectory planning. 3I/Atlas will pass within optimal observation range of each planet, maximizing potential data collection opportunities about their atmospheric compositions, magnetic fields, and moons. Dr. Alessandro Morbidelli from the Observatory of the Côte d'Azur noted that the trajectory looks almost designed to provide comprehensive reconnaissance of our solar system's major worlds. The object's velocity profile also shows subtle variations that correlate with planetary encounters, suggesting possible course corrections that natural objects shouldn't exhibit. Statistical analysis by Dr. Renu Malhotra from the University of Arizona concluded that the combined probability of all observed orbital characteristics occurring naturally is less than 0.001%, forcing serious consideration of artificial guidance systems. The hidden approach strategy. 3. iAtlas's approach timing demonstrates what researchers are calling strategic concealment that maximizes the object's ability to study Earth while minimizing detection opportunities. Dr. Paul Wiegert from Western University discovered that the object's perihelion passage in December 2025 coincides with Earth's position in its orbit, creating an observational blind spot that has a 7% probability of occurring randomly. During this critical period, 3I Atlas will be positioned directly behind the Sun from Earth's perspective, making detailed observation extremely difficult while allowing the object unobstructed views of our planet. Celestial mechanics expert Dr. Kleomenis Tsiganis from Aristotle University noted that this timing allows the object to study Earth's electromagnetic emissions, atmospheric composition, and artificial satellite networks without interference from ground-based observations. The approach strategy becomes more sophisticated when considering that 3Y Atlas will emerge from behind the Sun in January 2026 at optimal angles for both radio telescope detection and deep space communication. Dr. Seth Shostak from the SETI Institute acknowledged that if we were designing a reconnaissance mission to study an inhabited planet, this trajectory would be nearly optimal. The implications are unsettling. 3I Atlas appears positioned to conduct comprehensive Earth observation while maintaining plausible deniability as a natural comet. Scientific opposition and evidence. Despite mounting anomalies, many astronomers maintain strong skepticism about artificial origin theories for 3I/Atlas. Dr. Alan Harris from the German Aerospace Center argues that size estimates remain uncertain, and unusual properties don't automatically imply artificial construction. His team's thermal modeling suggests the object could be significantly smaller than initial estimates, potentially explaining some observed anomalies through natural processes. Dr. Vishnu Reddy from the University of Arizona emphasizes that interstellar objects should be expected to show unusual properties, since they formed in different stellar environments with unknown conditions. Counter evidence includes spectroscopic data showing absorption features consistent with water ice and rocky materials, though critics note these signatures could be engineered camouflage. Dr. Julie Castillo-Roges from NASA's Jet Propulsion Laboratory points out that we've only studied 3 interstellar objects, making it premature to define what constitutes normal behavior. The scientific opposition maintains that natural explanations involving exotic ices, unusual mineral compositions, or unknown formation mechanisms remain more plausible than extraterrestrial technology. Dr. Bonnie Barati from JPL advocates for continued observation rather than speculation, arguing that patience and data collection will eventually reveal natural explanations for these apparent anomalies. However, each new observation seems to strengthen rather than weaken the case for artificial origins. Ancient origins and anomalous behavior. Age analysis of 3I/Atlas reveals characteristics that seem to defy the natural aging process expected for interstellar objects. Dr. Grigory Fedorets from Queen's University Belfast estimates the object's age at over 7 billion years based on surface composition analysis, making it older than our solar system yet showing no signs of expected cosmic weathering. Objects drifting through interstellar space for such periods should exhibit significant cosmic ray damage, micrometeorite scarring, and surface oxidation, yet 3I/Atlas appears remarkably pristine. Most puzzling is the complete absence of a comet tail despite the object's approach to within 0.7 astronomical units of the Sun. Dr. Matthew Knight from the University of Maryland noted that any object containing even trace amounts of volatiles should be outgassing visibly by now, but we're seeing nothing. Structural analysis by Dr. Jean-Baptiste Vincent from the German Aerospace Center reveals density variations that are inconsistent with typical water ice spectra, suggesting either unknown materials or artificial construction. The object's rotation period of exactly 12 hours also raises suspicions, as natural bodies typically show irregular rotation rates due to impact history and gravitational perturbations. These ancient origins, combined with anomalous behavior patterns, continue to challenge conventional explanations. The stealth hypothesis. The concept of deliberate concealment has emerged as a serious consideration among researchers studying 3I/Atlas, potentially related to dark forest theory implications for interstellar civilizations. Dr. Liu Cixin's theoretical framework, popularized in science fiction but based on real game theory, suggests that advanced civilizations might prefer stealth over open contact to avoid potential threats. Professor Avi Loeb proposes that 3I/Atlas represents what he calls archaeological reconnaissance, a method for studying planetary systems while maintaining the cover of natural phenomena. This hypothesis explains why the object exhibits just enough anomalous behavior to suggest artificiality to careful observers while maintaining plausible deniability as a natural comet. Dr. Jacob Haq Misra from the Blue Marble Space Institute has studied the implications of such stealth strategies, noting that advanced civilizations might prefer observation over contact to minimize risks while gathering intelligence about other worlds. The stealth hypothesis suggests that 3I/Atlas could be collecting data about Earth's technological level, atmospheric composition, and artificial electromagnetic signatures while appearing to be a routine interstellar visitor. Radio telescope monitoring by Dr. Sophia Sheikh at the SETI Institute has detected no obvious artificial signals, but sophisticated probes might use communication methods undetectable by current technology or transmit data during periods when Earth-based observations are impossible. Lessons from Oumuamua. The scientific community's handling of Oumuamua in 2017 provides crucial context for evaluating 3I/Atlas and the importance of maintaining open-minded investigation. Dr. Robert Warwick, who discovered both objects, admits that we missed significant opportunities with Oumuamua by dismissing anomalies too quickly rather than pursuing thorough investigation. The 2017 visitor exhibited unexplained acceleration, unusual reflectivity, and extreme elongation that were initially attributed to natural causes without adequate investigation. Professor Abraham Loeb's controversial artificial origin hypothesis for Oumuamua was largely dismissed by the astronomical establishment, yet alternative natural explanations have proven increasingly problematic under scrutiny. Dr. Daryl Seligman's hydrogen iceberg theory requires formation conditions so exotic they approach the implausible, highlighting the difficulty of finding natural explanations for truly anomalous objects. 3I/Atlas represents a second chance to properly investigate an interstellar visitor with advanced instruments and sufficient observation time. Dr. Thomas Zurbuchen, former NASA Associate Administrator, emphasized that extraordinary phenomena deserve extraordinary investigation, not extraordinary dismissal. The lesson from Oumuamua is clear. When faced with genuinely anomalous objects, the scientific community must resist the temptation to force natural explanations and instead pursue comprehensive investigation that considers all possibilities, including those that challenge our current understanding of what's possible in the universe. 3I/Atlas continues its journey through our solar system, carrying secrets that may fundamentally challenge our understanding of what travels between the stars. Whether it's an exotic natural phenomenon or something more extraordinary, this mysterious visitor has already forced astronomers to confront uncomfortable questions about the universe around us. The patterns are too precise, the timing too convenient, and the behavior too strange to dismiss easily. Subscribe to Stellar Tech for more investigations into cosmic mysteries that blur the line between natural phenomena and something far more intriguing.